Hello there, I'm Mr. Math Guy, and today we're going to take a look at a 10-minute video on exponential and logarithmic equations. Before we begin to solve any equations, there's one thing that we need to know. It's called the change of base formula, and this will help us out. And this is if we have a log of a in base b, and we want to change it to a different base, any base that we want. So we're saying base c, then what we would do is we would take a log of a in base c and divide it by a log of b, log of b in base c. So if we want to change, if we have log in a base 3 and we wanted to change it to a base 5, all right, this is what we would do. All right, so this is going to help us when we work on solving some logarithmic equations. All right, in our first example, we have a problem like this. It says 3 to the x is equal to 32. So 3 to what power is equal to 32? Now, we could probably get some kind of a guess. All right, we know that 3 to the 0 is 1. 3 to the first is 3, so we're still not close to it yet. 3 squared, or to the second, is 9. 3 to the third is 27. Oh, we're really close. 3 to the fourth is 81. So you can see we're at 32. That's what we want. So we can easily determine that our x has got to be between 3 and 4. All right, it's going to be greater than 3 but less than 4, and it's probably going to be closer to 3 because 32 is much closer to the 27. So if I were taking a guess, I would say 3.1, I don't know, 8. I'm just taking a guess to 2 decimals. This would be my guess. All right, now, how would you do this problem then? By the way, it might be good to do just a guess so you know when you get your answer if your answer even makes sense or not, some common sense. So the way that you do this is, well, you can take the log of both sides. So convert this to a logarithm. All right, so if you take the log of both sides, as long as you do the same thing to both sides, notice my log is base 10. The reason I'm doing this is because our calculator can work in base 10, all right? So we have this right here. Now, using your properties of logarithms, exponent comes in front. Log of 3 is equal to the log of 32. Now, since they're both in base 10, you can go ahead and divide. And this is that change of base formula that we looked at a minute ago. So x is equal to the log of 32 over the log of 3. Now, here's where we can use our calculator because it's in base 10 now. All right, so since it's in base 10, just punch log of 32 divided by log of 3. And you get, when I type it in on my calculator, to 2 decimal places, 3.15. All right, so I was really close with my guess. I was only 3/100ths off. But this is a good thing to do, is try to maybe guess your answer. So then when you get your final answer, you say, all right, does my answer even make sense? And yes, my answer makes very much sense. So 3 to the 3.15 power, approximately, is equal to 32. All right, here we have a problem that is not an equation, but we want to evaluate this if we can. What is the log of 30 in base 3? All right, so what we want to do then is think of it this way. This is the same thing as 3 to what power is equal to 30, all right? That's what this really means. And so 3 to what power is equal, now it is an equation. And we do what we did last time. Well, we take the log of both sides, which is simply just going to be this at the end, log in base 10s of 30 over the log of what the base was in, 3. All right. Now they're in both base 10, so now you can use your calculator. Most calculators won't do a log in base 3. Most calculators are designed to do natural logarithms and log of base 10. All right. So we need to change them to logs and base 10s. And so here's how you do it. This is that A, all right, and this is that B. And you just take A and divide it by B. Use your calculator and you get 3.15 approximately. All right, that's what these little squiggly lines mean, approximately. 3.10 to the nearest tenth. All right. And you have to look and see what place value they want it rounded to. If they say to the nearest 10,000th, then it would be, I think, 3.0959. All right, so just look at what value they want it rounded to. All right, let's take a look at another problem. Maybe this one. Log of the square root of 13 in base 4. All right, well, we do the same thing here. If we want to figure this out, we need it in log in base 10. So you're able to change anything to log of base 10 by just taking the log of A and dividing it by the log of what B is. All right, so use your calculator here. Log of the square root of 13 divided by the log of square root of 4, not the square root of 4, just 4, is approximately 0.9251. All right, to 4 decimal places. All right, here we have an equation. 12 minus 5 to the y power is equal to negative 138. All right, so what we're trying to do is solve for y. So you want to get y by itself. So the first step then will just be to subtract 12 from both sides. So we get negative 5 to the y power is equal to negative 150. Next step would be to divide by the negative 1. So we want a positive value here. So 5 to the y is equal to 150. Now, we're close. We need to get this figured out. So what we do is we'd say, okay, you can take the log of both sides. The log of 5 to the y power is equal to the log of 150. That's how you solve exponential equations. You take the log of it. Now, when you do this, the properties of logarithms say move that exponent to the front. So it's y log of 5 is equal to the log of 150. Now, since this is being multiplied, you can divide by the log of 5 from both sides. And we have it in base 10, which is what we want. So this will cancel. And so we have y is equal to the log of 150 in base 10 divided by the log of 5 in base 10. Now here's just where you use your calculator. So log of 150 divided by the log of 5 is approximately 3.1133. All right, so does this make sense? Well, 5 to the third power is 125. 5 to the fourth power is 625. So does this make sense? We're looking for log of 150. Does 150 fit in between there, between 3 and 4? Yeah, and it's much closer to 3 because 150 is much closer to the 125. So this answer does make common sense as well. All right, let's look at a logarithmic equation. Log of 4x minus 2 is equal to 2. What do you do here? Well, you convert it to an exponential equation. Remember, the base here is 10. So what this means is, when you're converting to exponents, it means 10 to the second power is equal to 4x minus 2. It's that converting to exponents that we learn to do when we convert from logs to exponents and exponents to logarithms. Now, 10 squared is just 100, is equal to 4x minus 2. Solve for x. So we get 102 is equal to 4x. Divide both sides by 4. And we get x is equal to 25.5, or 25 and 1/2. All right, one last example. We have a logarithmic equation. We need to convert this into a single logarithm. So since they're being added, that means they're being multiplied, properties of logarithms. And 3x times x is 3x squared. Converting it to an exponential equation, we get 3 to the 9th equals 3 to the times x squared. Using our calculator, we figure out 3 to the 9th and divide by 3, so we get x squared equals 6,521. We take the square root of that, and we get plus or minus 81. Negative 81 wouldn't make sense with logarithms, so x is equal to 81. God bless.